One of the really great features of Griddler 2.5 Pro is this database of cell parameters, which are periodically updated and then downloaded onto the software automatically via the internet connection. So the best way to show this database is to actually give an example. Let's suppose that we're trying to simulate a localized backsurface field cell or a perk cell, and we just want to look up some state-of-the-art cell parameters related to this cell. Let's have a look at the diode recombination parameters first. So you'll notice that in Griddler Pro, next to each box is this question mark button. So for example, if we click this one next to J01 of the front passivated area, we get a list of reported or suggested values. So the values are shown on this first column. There's a short description of what particular cell type and process created this value. And then if we scroll over, we also get to see who did this work. So in our case, we would like to scroll down until we find some relevant number. And then we find the right keywords: p-type, mono, perk, with a phosphorus emitter. That's 60 ohms per square in sheet resistance, achieving a value of 112 femtoamps per centimeter square. Down below it, we see that if we go with what's called a selective emitter, we can get even better values or lower values of 26.3 or 65 femtoamps per centimeter square. If we click any of these, the number shows up in this box, and then if we hit apply, this number is transferred into the box in passivated area front J01. So that makes our lives really easy, and it's a great way to get up to date with the most recently reported parameters. By the way, if you want to find the literature which reported this number, just press Get Source, and we'll be directed to the publisher's webpage from which you can download or purchase the article. So in this case, we're looking at the 22.13% efficient perk cell, which was presented by Trina Solar at the IEEE PVSC conference in 2016. So by the way, earlier in the Griddler simulation video, we explained that each node in Griddler is represented by a J01 and J02 diode, and the value of the J01, J02 are the sum of the contributions from the front plane and the rear plane. So in this case here, when we press the question mark to look up suggestive values, the suggested number is actually referring to the contribution by the phosphorus emitter. So later on, we need to be sure we also add the contributions by the base of the cell and put in those numbers into the J01 and J02 belonging to the rear plane. We do the same for the J0 at the metal contact, and here are numbers that are reported by the same group of people. So recombination parameters under the metal contact are reported in pairs of J01 and J02 values. If you click it and apply, both of these values will be inserted into the corresponding boxes. J02, we could use the following values as suggested by Syncast and others. Now onto the rear plane. Remember, in this context, this refers to recombination in the base. If we hit the question mark next to J01 in the passivated area, we may also select from the list here. Now for perk cells or localized BSF cells, the base recombination can be calculated from the wafer bulk lifetime, rear passivation surface recombination, and the rear local dielectric opening recombination. So Griddler Pro is equipped with a rear local contact calculator for perk cell designs to make things really convenient for the user, and we're going to cover that in a later video. So for now, we just used the first suggested value and hit apply. Our solar cell model right now consists of a H-pattern front grid and a full area rear metal contact. So practically, the entire area of the rear is metal in the Griddler model, even though the perk cell we were trying to model actually has a rear passivation with only local metal contact. So in this case, it makes sense to enter the J01 and J02 values for the passivated area into the metal contact as well. So these J01, J02 values are kind of effective parameters applying to the entire rear plane. 1 sun JL in the non-shaded area. Typical values are in the mid-41 neighborhood. Finger contact resistance, we could use this value. Rear metal sheet resistance for aluminum is typically something like 10. Okay, let's have a look. So if we run the IV curve, we get the IV parameters for the perk cell. So the VOC is not too bad, JSC is pretty good. Fill factor is low, mainly because the second diode has high recombination, maybe the cell is not very linear, and the efficiency is somewhere in the middle of 20%, which is not bad and has room for improvement. So we have shown you an example of using the database to quickly look up and apply parameters for a PERC cell. There are also parameters related to N-type bifacial, monofacial aluminum BSF, multicrystalline solar cells, as well as related to particular processes like selective emitter or passivation by silicon nitride, aluminum oxide, silicon oxide, and so on. So not only is this a very convenient feature of Griddler 2.5 Pro, but it's also very educational, and the user can learn about the breakdown of the solar cell component and its properties in different cell types. The database is also constantly updated, or if you find parameters that should be in the database but is currently not, let us know and we'll be most happy to add the relevant numbers in to everyone's benefit.